Those boogies. So which cookie has the most chips? Okay, is there a difference in the number of chocolate chips in the Chips Ahoy cookies versus the number of chocolate chips in the off-brand cookies? Due to the factory processes, we can assume the population distribution of the number of chips are approximately normal, that the samples are random. Okay, so half of the students in the class get a Chips Ahoy cookie, and the other half gets the off-brand cookie. Dissect the cookie and record the number of chocolate chips on the board. Obviously, I don't have chocolate chips cookies today because they were on my counter. It's not my fault. That is a weird thing to do, like pull it apart. Like, scalpel. Yeah. All right. So what we're gonna do is we would find like the mean, the standard deviation, and then the number of samples. So let's say that in one is 16. Okay, 16 of you did this, and you got 2.49 for the standard deviation. And then for the mean, you got 21.56. For the off-brand cookie, you got 18.22. Standard deviation was 4.51. Into was 15. Okay. For the degrees of freedom on this one, it should be 14, and the degrees of freedom on this one would be 15. All right, so the difference between x1 and x2 is 3.34. All we did was we subtracted these two. Solid, good. All right, so now we're going to construct and interpret a 95% confidence interval for the true difference in the mean number of chocolate chips in Chips Ahoy and off-brand cookies. Assume the conditions have been met. Okay, so we're going to choose our procedure. This one is going to be a 2-sample t-test. My handwriting. 2-sample. The lag is real. T. I promise it's the thing. I'm going to. I'm over it. I'm over it. Okay. So 2-sample t-test. This is like serial killer handwriting. Like, this is so bad. This is so bad. Okay. mu1 minus mu2. Okay. The 95% confidence level, like I can't even write a 5. Like, this is stupid. All right, parameter. Parameter is going to be mu1 minus mu2. That's it. I'm using the text box. Okay, mu1 minus mu2, which is equal to the true difference of mean number of chocolate chips. Look at that handwriting. Boom. All right. Yes.
What does it say after confidence or confidence level?
95%. That's not funny, Victoria. You might be right.
Cover up your
Took me like 13 minutes to get the HDMI cable to work this morning. So like this is on par for today. Oh, there's so much to do. It's not even funny. All right, let's see if I can get this next part. The general formula. Oh God. All right, that's going to be your point estimate plus or minus margin of error. No, here's the hard part. Specific formula. This might be really bad actually, but we're gonna try it. Okay. So for specific formula, please just let me get through this formula. We've got x1 minus x2, little bars over them, parentheses, plus or minus the critical t value, square root of s1 squared divided by n1 plus s2 squared divided by n2. Look at it. We okay? I mean, it's the same thing as like last time. The only difference is like we're finding the difference between the means, not just a point estimate. Okay, so yes, thank you. Appreciate you. No.
What's up, guys?
Oh my God. Plug in the numbers. I'll get it in a second. Just leave it. 3.34 plus or minus. And this T critical value, remember, we use the T table. Our degrees of freedom is 14. And then our confidence interval is 95%, right? You always use the lowest degrees of freedom between the two samples. Everybody hear that? Okay. Yep, you use the lowest. No, Mo. Sit down, Mo. I hope so. Today's gonna be the day that Mo learns something. I know, it's gonna be great. Gonna have a good day. All right. So then we've got S1, which all this information is up from the top. You've got 2.49 squared divided by 16 plus 4.51. Dude, this just keeps getting worse. What's up? Love y'all, respectfully. All right, over 15. So you're gonna put all that junk in. Plug all that junk in. I don't want this to work. Y'all gonna keep it coming in here like clowns out of a clown car. Yeah. No, you gotta do it two separate things. Normally what people do is they simplify like the right-hand side of that equation, and then they go that plus the simplified version. Yeah, in a minute. We're in here for 2 hours. We got time. Yes, welcome to the party.
Are we actually?
Yes, Mo. Why would I lie to you? Aha. You thought.
Wait, are we or we not?
Yes, we are. Like, yeah. All right. For the answer, you're going to get 0.51 to 6.17. There is a way to do this in your calculator. I'm going to show you a little bit later. This is called a two-sample PINT. And when you say pooled, it's going to be no. And then from 0.6 to 6.08. And the degrees of freedom are going to be 21.5057. I'm going to show you how to do that a little bit later. We're going to talk more about that in a second. Just go ahead and write it down, though. All right, we're going to conclude. This is the same conclusion statement as what we did in the last section. Okay? So we are 95% confident that the interval from 0.51 to 6.17 captures the true difference less of mean number of chips. And that's Chips Ahoy minus the other terrible cookie. minus off-brand. Did anybody just wake up late today? So do we have convincing evidence that there's a difference in the average number of chocolate chips in Chips Ahoy and an off-brand cookie? So think about it. Are these two numbers positive? Yes. So they're both positive, which means that it's probably that Chips Ahoy has more than the off-brand. Okay. We always want to say all of the plausible values in the interval are positive. The plausible, that's going to be keyword. I'm going to write this up. Yeah. So yes, because all of plausible values in the interval, bless you, are positive. If they include 0, that's when there might not be a difference. So if there's a positive and a negative, it's probably not much of a difference. But since they're positive, then yes, Chips Ahoy is going to have more. No, 0.6. 0.6. We're doing great. We're winning at life. Flip. Okay. We had the choose, check, calculate, and conclude. So we had the 4 C's. Shocker. So we're going to choose, which is a 2 sample C interval for M1 minus M2 plus. Then we check, and that's going to be independent random samples, 10%, and normal large sample. Remember, we're going to multiply that by 2 because we're going to have it on both sides. Calculate is that formula from the front. And then conclude. We are, whatever the percentage is, confident. So nothing really new going on there. We also learned how to evaluate a claim. Same thing as last time. If we have both plus plus on our interval, then that means that we have convincing evidence that first mean is greater. If we have a minus minus, we have convincing evidence that first mean is less than the second. And if we have minus plus, we have no convincing evidence of a difference. And I'm gonna read very slow. Okay. A large publishing company conducts an experiment with the hopes of finding ways to increase the amount of time that people spend reading. 2,025 volunteers were randomly assigned into 2 treatment groups. One group of 975 people was not given any reading materials, while the other group of 1,050 people were mailed books that matched their interests. Here are the summary statistics for the average amount of time spent per day reading. All right, so construct and interpret a 95% confidence interval for the difference in mean amount of time that people read per day. So the first thing we got to do is choose. Okay. So we choose a 2 sample T interval for mu1 minus mu2. The confidence level was 95%. And then mu1 minus mu2 is the true difference in mean amount of time reading. And that's no books minus the mail books. Yep.
Why can't we just do X bar 1 minus X bar 2?
Why can't we just do x1 bar?
Does it matter?
I mean, it's just talking about the difference between like the different variables that you use is talking about a sample versus a proportion versus a population. Like, so this is a sample. And this is not like every person in the world that we pulled from. Does that make sense? Okay, so for checking, so for check, we're going to do random assignment. This is so we can show causation. A little different from what we've seen in the past, but not really. Could still generalize it to the population, but we're showing that it's causation because it's not all people in the world. Okay, 10% is not necessarily needed because our population is so small. So no sampling without replacement is going to happen. Huh? It'd be every person in the world. Because what are they trying to find? The difference between, and we can't calculate that for the entire world, but they found it for this group of people, right? Normal or large sample, we have 975, which is greater than or equal to 30. And we also have 1050, which is greater than or equal to 30. The CLT plus. So this is approximately normal. Questions? Yep. CLT, that's my number. It's gotta be greater than or equal to 30.
That's good.
It's not necessarily needed because the sample is so small. And we're not talking about a population, we're just talking about the sample of the volunteers that were given. We can show causation, but we're not going to generalize to the population because we didn't talk about a population. We just talked about a sample of people. Like that 2,000 and they're volunteers. This is not everybody in the US or everybody in high school. Does that make sense? Okay. For calculating, we're going to use point estimate plus or minus point estimate plus or minus the margin of error. And then we're going to plug all the information into that formula. So for calculate, we're going to do point estimate plus or minus the margin of error. So we got x1 minus x2 plus or minus p s1 squared divided by n1 s2 squared divided by n2. We're going to plug in. So here we got 7.8 minus 43.8, and that's given up at the top. And then we're going to say plus or minus. What were our degrees of freedom on this one? Remember, we used this smaller one. 974. Okay. You're going to look at your critical value. Yes. So you wouldn't use 1050, you would use 975. And so the degrees of freedom would be 974. We want a confidence interval of 95%. So we're going to go over, and you should have gotten a critical value of 1.984. Make sure that you can do that on your old table. Okay. No, so you would use the one that's below it. So it would be 100, we would go over to 95% from the bottom, so it would be 1.94. Yeah,
Wait, do you have up or down?
down. Well, it was drawn down for T.
So we're not measuring?
Yeah. Okay. When we take the square root, we're gonna do 5.4 squared divided by 975, and then plus 35.5 squared divided by 1050. When we plug all that junk in, we're gonna get an interval between negative 38.2 and negative 33.8. All right, so you're going to hit a new page, go to calculate, okay, then you're gonna hit menu. So you're gonna hit menu, and then you're gonna hit statistics, and then you're gonna go to confidence intervals. First of all, Mo. And then you're gonna do 2 sample P interval. And interval. Then you're gonna do statistics because they gave us the data. So you're gonna hit that. Should have popped up too. Yeah.
Yep.
Okay, so fill that stuff in. So you're gonna hit stats and then you're gonna fill in the information. Tell me what you get once you put it in. Not the whole bunch of numbers. Beans, greens, potatoes, lamb, chicken, turkey. Still the best thing ever. 5.4. What? You're gonna put no. That should be an option. Is it down there at the bottom? Yeah, put no.
Oh my God, what's new?
Bro. Like you're gonna bet.
Oh.
What was the no reading one? 975. I can read. It's fine. Everybody good so far? Okay, so then it gives you like a printout and it tells you the lower, the upper, the difference, the degrees of freedom. Yes? Okay, so it tells you all that information on there. Good? Okay. All right, so now going back to our page, we're doing the conclusion. So we are 95% confident that the interval from 38.2, negative 38.2 to negative 33.8 minutes captures the true difference, oh God, in mean amount of time reading. The interval captures the true difference in mean amount of time reading. No, you gotta say from this number to this number. Yep. It's super extra for no reason. What? Okay, is climate change real? It's the fact that it's like November and it's like 90 degrees one day and like 20 the next. It's fine. By the way, least favorite time of my life, moving a couch in the pouring down rain. Least favorite moment. Okay, so to find out, we will take a random sample of locations around the globe and find the temperature at that location from 1900 to 1940 and compare it to the temperature at the location from 1960 to 2000. Dope. Okay, so instructions to obtain a random sample. So use a random number generator to get a random number between negative 180 and then 180. That's your longitude. Do you remember what longitude and latitude are? Longitude, latitude. And a random number between negative 90 and 90. Good? Okay, so since you're not doing the thing, negative 156 and 20 for your latitude. Yeah, I don't touch all the samples anymore. Absolute garbage. Respectfully. Yeah, you had the whole John Jennifer thing. Notice how we haven't been able to do a Chips Ahoy cookie? Can't even trust you there. All right. So go to tinyurl.com/NASA globe, select the dates above from the globe to be from January 1900 to January 2000. Choose this one and then click updates. So I'm going to just show you what the website looks like since all of you aren't going to do it. Here's a globe. Thank you. Not sparkly. Very not sparkly. Okay, so this, you would change it to January 19. Come on. Clear. Go, buddy. January. No. Okay, two. What did it say? January 1940?
It's supposed to set the date from January 1900 to January 2000.
There it is.
So if you're paying attention, you'll be
First of all, most it. I was trying to come up with a different name. This is not working. All right. Below the globe, type in your randomly selected latitude and longitude, then click recenter. Okay, so I'm going to come down here. And what was our longitude? Bo. You weren't even paying attention. Bo. Like again. Bo. All right. Wow. Yeah.
No, it's 54 hours.
So hover over your chosen station and click generate thought. Is that what that is? There's no way that's Hawaii. Hawaii is not that far out there. That is not Hawaii. Is it really that far out? Okay, I'm too poor to know. It's fine. Okay. All right, so now what do we do? Enter station. Hawaii? Is there two eyes? Say again?
Wait, no. It's like by the station. So I think the red dogs are the center.
So she's going to, I think we might need to, yeah, we need to read
No,
Okay.
Hawaii doesn't have a station.
that is.
You're failing my class.
I already am.
It's not the end yet. Okay, so we don't have a place here. The nearest station. The nearest station would be this guy, right? Well, we're gonna fight. That one?
Yeah.
Okay, so we're gonna click this one and we're gonna click generate plot. Find the highest point between 1900 and 1940 and estimate its temperature in Celsius. All right, so what's the highest? Like here? Okay, so what is that? 26.75.
After.
Say again.
That point after 19.
That's a good, yeah, after 1940. 26.75. And then do the same thing for before as well. Okay, so the after is going to be 26.75. The before is going to be like 26.5. Okay, so let me help you. So on here, I don't remember what the name of that one was.
APIA.
Okay. All right. The low temperature was 26.5. The high temperature was 26.75. And the difference between these two was 0.25. Does it matter? No. Okay. So if we all did this with no repeats, like we wouldn't get the same location, etc., we're going to use the data that I don't trust you with, and we're going to put it all on the board. So it would look roughly like this. One dot here, one dot there, one dot there, two dots there, two in between, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So how was everybody's weekend? Yeah. I yelled at my realtor yesterday. Oh, it was good. It was good. And it was the moment where my fiance saw me lose my mind for the first time. It was a really great moment for him. Well, like, okay, I'm very cool, calm, and collected. But yesterday, first of all, Mo, first of all, that's okay. Yeah, it's fine. It's fine. I'm gonna pause. We'll be back. All right, and we're back. So, with that being said, all right, we know that there's no difference when we have 0, right? Okay. If we have anything over to the right, good Lord. All right, if we have anything over to the right, that means that the peak temperatures increased, right? That means after 1940, we went up. Mo, are you writing this down? I don't believe you. If we were less than 0, the peak temperatures decreased. Okay, the mean difference, if we took all of these numbers, added them up, and divided by how many numbers there are, I would get 0.35. For standard deviation, I get 0.296. For the N, let's say that there were 32 of you. What? What? Oh my God. All right, flip the page. All right, so this is what we call matched pairs T interval. Matched pairs T interval. What'd you say? What? Yes. Yeah. I know. It's a lot. Matched pairs T interval. This is also known as a one sample t-test. Yes. For mu difference. Yeah, but this is what its common name is. Kind of like you go by one name. Your nickname is this.
Oh, your name's Taylor.
I will. I'm gonna get the 4-year-old on you.
Wouldn't you do this?
No,
Wait, that was your first mistake.
Mo.
Later.
I hate all of you. Respectfully. All right. Is the true mean difference in peak temperatures? I always think it's stupid to check the conditions, but that's just because we've been doing it for the past like 5 chapters. It's fine. No, you have to check them. Okay.
Always true anyways.
They weren't true in the last one.
What do they care about the last one?
I don't know if that is how it goes. Random sample of 32 stations. Okay. We can generalize to all of the stations then. For your 10% condition, you've got 32, which is less than 10% of however many stations there were, which was 1,913. Pull that number from like the website. I'm gonna just trust you. All right, and the last one is normal or large samples. Yeah. So is 32 bigger than or equal to 30? Yes, because of the CLT. So we can be approximately normal. Thank God. Guess what the general formula is? No, general formula. This is the word one. Point estimate plus or minus Mo. Mo, you totally missed it earlier. I was like, man, we're gonna get so much done today because Mo's not here. And then you walked in the door. Respectfully. It's fine. That's fine.
That's how my mom.
Please do. Mo, please do. Call her I said hey girl hey. Respectfully. I kid. Okay, so this one looks a little different, but really it's just the summary of what you've already been doing. So you've got X bar plus or minus the T critical value. Cool, that's the same. Times the standard difference over the square root of N.
Oh, it's very good. Oh.
Sorry, I'm so glad you had that conversation with yourself. It's okay. Okay, because we already found all that junk on the front page. Yeah. All right, so let's go ahead and plug it in. Plug it in, plug it in. All right, the critical value. Remember, we're going to use the degrees of freedom 30. And we're at a 95% confidence level. So make sure that you can read a table. Okay, and you should have gotten 2.042. We're going to multiply it by 2.296 and divide it by the square root of 32. So when you plug all that junk into your calculator, you're going to get 0.24 to 0.46. A lot of people make a mistake on the plugging in the right side of the equation. Got to make sure you type it in correctly. Yeah. We are 95% confident that Mo is not writing his stuff down.
I already wrote it down.
No. That the interval from 0.24 to 0.46 captures the true difference in peak temperatures. Wow. Progressively getting worse. We are not. Is there convincing evidence of climate change? Plot twist. Yeah. I know, right? All right, because of the interval contain plausible values that are all positive. Plausible. Wow. That are positive. Because of the interval, it contains plausible values that are positive. It doesn't contain zero. What? I think so. I need to check my email again. That's from the last time. That's what I mean. Yeah. I flip the page. No. Yeah, bro. Oh. All right. Oh my God. All right. So we did choose, and that's one sample T interval for mu difference. We checked the conditions. We calculated using that cool formula. Then we concluded that we are blank percent. Ooh, blank. Nope. Blank percent confident. Okay. Then we talked about distribution of differences. Distribution. We had 0 in the middle. If it was positive, it was over here. If it was negative, it was over here. God bless. All right. So go ahead and take a moment. Go ahead and try. All right. So do parents realize how many hours their children are spending online? Wow. All right. So construct and interpret a 90% confidence interval for the true mean difference in the time spent online. So we're going to choose. And that's going to be a one sample T interval for mu difference. 95% I'm sorry, 90%. JK. Confidence. And then mu is the true mean difference in time spent online. Wow. Okay. We got a random sample. We have 10%, which is 10 is less than or equal to 10% of all teenagers. We got normal large sample. That's the distribution of differences. It has no strong skew or outliers. So we can say that it is approximately normal. No. But yes. Okay, so everybody good on the check part? First she called me Tater Tot. Now you're calling me a man. What else are you gonna do? Mo.
I will say, I was on fun too.
I'm strong. All right. So then we're going to calculate. And so we're going to do X bar plus or minus the critical value of S difference divided by the square root of N. So that's going to be 3.02 plus or minus 1.833 times 1.316 divided by the square root of 10. You should get Your degrees of freedom is 9. And we have a 90% confidence. So we're gonna get 2.25 and 3.79. Duh. So the conclude part is we are 90% confident that the interval from 2.25 to 3.79 captures the true mean difference in time spent online. Since it's positive, what does that mean? 4. So the actual time is greater than what the parent perception is. Okay, I gave you 10.1 worksheet. What I'd like for you to do is go ahead. What? Yeah, because you're in your seat, Mo. Here you go, Mo. Okay, so I'm gonna give you about, let's do 30-ish minutes, and then we'll check our work. And then I'm gonna give you a second one. It's 10.1 and 10.3. Those are the two main things in this section. Okay. Remember, we're gonna have a short little test tomorrow over this stuff. Short. Your FRQ is gonna be one of these 4 C's kind of thing. I know. I know. Listen,